Right, in our earlier class, we started discussing on this topic OSPF, Open Shortest Path First. Open Shortest Path First. Do anyone remember what OSPF stands for? Exactly. Now, there is an algorithm called SPF, which is used in this routing protocol. And this routing protocol is also an open standard. So the name itself has become OSPF, Open Shortest Path First. See, SPF is just an algorithm that is not a routing protocol. SPF is seen in various places. Even your Google map shows it uses SPF, shortest path first algorithm. We used to call this as binary tree algorithm in our college days. Dijkstra's algorithm. All are same. Right now, O stands for open. A routing protocol, which is open standard, uses this algorithm called SPF. So the name itself has become OSPF, Open Shortest Path First. Now in Cisco, the importance given is, means we call it as administrative distance, is 110. OSPF's administrative distance is 110. Do anyone remember any other protocols administrative distance? Mhm. No, exactly. RIP is 120, EIGRP is 90. So if I run one only one routing protocol, this number doesn't matter. But if you run in same router, OSPF and EIGRP, the router will follow EIGRP's direction, not the OSPF. Because EIGRP has got 90. Administrative distance lower is preferred. Administrative distance lower means more weightage to that protocol. More important is given to that protocol. Fine, that is AD value, administrative distance value. And when we talk about the metric is auto-calculated. Auto-calculated using what? Using bandwidth. I just typed the BW, bandwidth. So depending on the bandwidth, the metric will be different. If you have more bandwidth, metric will be less. I repeat, if you have more bandwidth, metric will be less. Yes or no? If there is too much of tomato grown, the rate will be cheaper, no? In mango season, mango is very cheap. But in the month of December, if you try buying one mango, first of all, you won't get it. If you'll find anywhere, then it will be very costly. So more the bandwidth, less the metric, right? So bandwidth with less cost. For example, if this is 1000 meg, and this is 100 meg, and this is 10 meg. Tell me for which the metric will be less, for path 1 or path 2 or path 3. For which the metric will be less. You're just saying the opposite. I just finished saying to you that more bandwidth, less metric. More bandwidth, less metric. So first of all, I would like to take this two number and give you the cost. From this router 1 to reach this network 1.1.1.1, you have two paths. See, this path has got more bandwidth, so metric should be less. Why, you know? Metric less is preferred. Right now, if you're going by aeroplane to London, you will compare which flight is cheaper. That is what preferred flight, isn't it? Metric small is preferred always. If you have 100 meg, then the flight charge will be less, meaning you have 100 flights going to London. Compared to 10 flights going to London, when there is 100 flight going to London, they will reduce the cost. Why? Competition. More bandwidth, less cost. Okay, I'll give you another example. You're going in a car. Which road will take more petrol? The road with the fully crowded and narrow, or the road which is very broad, Ettuvari Salai? Which one will take more petrol? One Valley Salai or Ettuvari Salai? Which will take more petrol? ஒரு வழி சாலையா எட்டு வழி சாலையா இதுல போனா பெட்ரோல் ஜாஸ்தியா வந்துருங்க. ஒரே வழிதான் இருக்குன்னா கன்ஜஸ்டடா இருக்கும் ரோடு, அப்ப பெட்ரோல் அதிகமா சாப்பிடும், மெட்ரிக் அதிகம். அகலமா இருந்துச்சுன்னா ரோடு சர்வன் ஆக்சிலேட்டர் அழுத்தி போயிட்டே இருக்கலாம், ஃப்ரீயா இருக்கும். அகலம் கம்மியா இருக்கிறத விட அகலம் அதிகமா இருக்கிறதுக்கு மெட்ரிக் கம்மி. மெட்ரிக் கம்மியான பாதை தான் தெரிந்து கொள்ளப்படும் பாதை. The path whose metric is lower is the preferred path. Okay, so you got router 1 with two paths, and the metric of path 2 will be lower than path 3. Now, how is the metric calculated? This is how. OSPF cost is equal to, we call metric of OSPF as cost, auto cost. Cost is equal to 100 by bandwidth. So here 100 by, what is the bandwidth? 100. What is the cost? 1. Cost is equal to 1. For path 2, cost is equal to 1. For path 1, 100 by 10. What is the cost? 10. Yeah. So cost 1, cost 10. Which one you prefer? Of course, cheaper cost. See, bandwidth is more, cost is less. Brain, புரிஞ்சுதுங்களா? So it is opposite, okay? More cost, less, sorry, more bandwidth, less cost. Path with the low cost is preferred. Okay, so that's about the metric of OSPF. What is the metric of OSPF? Okay, so assume I am an interviewer, I'm asking you a question. What is the metric of OSPF? What should be your answer? I'll tell you the answer. What should be answer? Answer is cost. The metric of OSPF is cost. And the cost is calculated based on bandwidth. Cost is equal to 100 by bandwidth. More the bandwidth, less the cost. Path with the low cost is preferred path. These are all the statements that you should say for that one single question. What is the metric of OSPF? Cost. Cost is measured based on bandwidth. Cost is equal to 100 by bandwidth. More the cost, less the, more the bandwidth, less the cost. Path with the low cost is preferred. Now in CCNP level, when you come, you should tell more. What is that? This auto cost can be manipulated, meaning you can change this numerator. Anyway, the CCNA interviews won't ask you those things, so you can ignore now. When you come to CCNP, I'll teach you the other side of this. Now, as of now, you should know one thing, like metric of OSPF is cost. Cost is measured based on bandwidth. More bandwidth, less cost. The path with the less cost is preferred. And the formula is 100 by bandwidth. Any question? Now, in the database, which is called as linked state database, you will have both the path. But in the routing table, you will have only this path. Why? Because the cost is low. If this path goes down, immediately this path will be promoted to the routing table from the database. Immediately from the database, the second path will be promoted to the routing table, provided the primary path is down. If this path is available, this path will not come to routing table. It will be only in the database. OSPF topology table is called as linked state database. In EIGRP only we call it as topology table. In OSPF, instead of calling it as topology table, we call it as linked state database. Why it is called as linked state database? By collecting the linked state advertisements from every router, this database is built. By collecting the linked state advertisement from every router, this database is built. So linked state advertisements, LSA, collectively called as linked state update, gathered in one location on every router, that memory location is called as link state database. That's why OSPF is called as link state routing protocol. Link state routing protocol. Link state routing protocol. OSPF is not a distance vector protocol. OSPF is a link state routing protocol. Why it is called as link state routing protocol? Link state advertisements that are sent between routers makes the router to discover the topology which is saved in a location called LSDB. On this LSDB only, the algorithm SPF will run and find the shortest path. SPF will compare the cost. This cost is 1, this cost is 10. So SPF will say, put this path 2 in the routing table. SPF will pick the path 2 from the database and place it into the routing table. Shortest path first algorithm runs on link state database. Don't forget. See, if you want to go to metro station from your office, if you're new to the place, you want to go to metro station, what do? You take a map. Assume you don't have the navigator. Assume you don't have a cell phone. But you have a map there. In the notice board, there is a map. Now, you have a map which is called LSDB. So with your brain, you are seeing which path is shortest path. Your brain will calculate, okay, there are 2 routes. From office to airport, there are 2 routes. Let's say you are in Solinganallur. From Solinganallur to airport, at least 2 routes. One, you go via that Medavakam, Madras Christian College, Tambaram, take right, keep going, Pattabhuram. After Pattabhuram, before Katipara, you have the airport in the left. The other route is keep going straight Adayar from Solinganallur and then take left. Keep going, Valacheri will come. And then Gindi will come. And then Katipara will come. Then take left. There is also another route. From Solinganallur, take right towards the Mahabalipuram. I don't know the exact place name. Take right there, you will meet in Vandalur. Take right again, keep going. Tambaram will come, Pattabhuram will come. And then you will be in the airport. Now there are 3 routes discussed here. Which one is shortest? Your brain will say, go via that Madras Christian College. Go via that Medavakam. That is shortest. From that Solinganallur junction. That is what SPF is doing here. LSDB will show all possible paths from Solinganallur to airport. All possible paths. Like a map. Now SPF algorithm calculates the distance going via Adayar, going via Vandalur, going via Medavakkam and Tambaram. Okay, so I hope you understand. I hope you understand the meaning of LSDB and the SPF algorithm. Hmm. Fine. Next is we have spoken only three things. One, OSPF is a link state routing protocol whose administrative distance is 110, whose metric is cost. Cost is automatically calculated based on the bandwidth. Now, if I am a very bad interviewer, if I am a crooked interviewer, I may ask this question when you are in a CCNA level. You should not. I should not ask this question. But if I'm a crooked guy, I'll ask you this question. What is that? You said metric is calculated based on bandwidth. Is there any way you can cancel it? Yes. If you will assign the metric manually, see, this is auto calculated. Auto. If you go under the interface and put the cost, say for example here, if I say cost as 1, then this auto cost will not be effective. So we can manually set the cost, which most of the people will not do. We will only go with auto cost. But there are some situations where you want to have your own path. You don't like the OSPF preferred path. You have some good reason to prefer this path over this path. So you can go and set low cost. It is allowed. But most of the OSPF speaking people will only talk about auto cost. That's why I said, no, I'm a crooked interviewer. So I'm asking you this question. Can we assign costs manually? Yes. Next is OSPF supports any size network. Any size. There is no fixed size. In another word, there is no limitation. OSPF supports very large size, also small size. But when you go larger size, you need to do some fine tuning, which we'll be learning in next level of our training. But here we are learning the fundamentals of OSPF, very important basics of OSPF. Here we have to take this point. What is that? OSPF don't have any limit. It can support any size network, large, medium, small. Will you recommend RIP for a large size network? No, we won't. We won't recommend RIP. But OSPF don't have such limitation. You can recommend it to anyone, anywhere. Supports any size network. How is this possible? OSPF follows two-tier architecture. Two-tier architecture. OSPF follows Two-tier architecture, hierarchical design. So the design will help us to have proper tuning to accommodate large networks. The design, the hierarchical design helps OSPF to support any size. For example, you will have one area and that number will be always 0, through which you can connect two different areas. So let's say the routers in this area 1, routers in this area 2. Now members of area 1 and area 2 are connected via area 0. Like this, you can have any number of areas. And now, because you have areas, the networks of area 1, when it is sent to area 0, it will be sent in a summary. A summarized one. So not much bandwidth is going to be taken. On the receiving areas, not much space and CPU. It won't be consuming much CPU and space because you are sending the summarized routes. What is summarized route? If I have 255 networks here, how many networks I have? 255 networks, assume, in this area. I'm just sending one summary, just only one. Only one summary route, not 255. Because you have area, you get a nice border. If you don't have area, will there be any border? No. Because you have area, you have border. Correct, no? Because you have Andhra Pradesh, Kerala, Karnataka. These are all areas. Because you have these areas, you have border. Pundi, after Tiruvallur, is the border between Tamil Nadu and Andhra Pradesh. That's one of the border. Hosur, border between Tamil Nadu and Karnataka. That is one of the border. Even via Ooty also you can come into say Karnataka. I'm just telling. Because you have areas, you have border. If no area, then all will be in one group. Then you will not be able to summarize. So because you do summarization, you don't send too many updates between areas. As a result, more networks can be accommodated. In this way, OSPF can support large networks. OSPF follows this hierarchy design. Now in OSPF, there are 3 IDs. Number 1, area ID. Number 2, process ID. process ID. Number 3, router ID. You see, router ID is to identify the OSPF router. OSPF running router. Process ID, okay, router ID is global, meaning you cannot have two routers. You cannot have two routers with same router ID. Two routers cannot have same router ID. Every router must have unique router ID. Next is the process ID. That is local, not global. To identify OSPF process running on a router. So you can have more than one OSPF on same router. You can have more than one. Then how do you differentiate this and that? When you have more than one, how do you differentiate? With the help of process ID. Not only that, when the process ID is different, even the router ID will be different. So if you will run two OSPF on same router, each OSPF will have their own router ID. For example, you see this in this router, I have loopback, two loopback interface and two physical interface. And let's say the IP address on loopback interface is and the IP address on the physical interface is now when you enable OSPF, when you enable the first OSPF, let's say you are enabling a router OSPF 1. This is the process ID. As soon as you enable the first OSPF, you can manually give a router ID. I repeat, you can manually give a router ID, but if you don't give manually, it is going to compare the loopback IP addresses and it will take the biggest IP address as the router ID. So OSPF 1 has taken the router ID 5.5.5. Automatically it will take this if you don't give. You can also manually give. You can give any IP address as a router ID, even if it is not in the router, no problem. You can give manually, but when you don't give manually, automatically it will pick one biggest IP address from the loopback interface. Now let's say I'm creating another OSPF. Router OSPF 2, same router, I'm creating another one. This time it will not take 555. Why? 555 is already taken by OSPF 1. So it will automatically take only this one. Automatically it will take this. See, if there is a loopback interface, it will not take from physical interface. Even though the physical interface IP address is big, 50, 200 is bigger than this, it will not take. First preference is given for the manual configuration. If you don't configure manually, it will pick from the loopback interface. If you have more than one loopback interface, it will pick the biggest IP address. If one biggest IP address is already picked by one OSPF, when you create another OSPF with a process ID 2, it will look for another loopback interface. It won't use this one because it's already used. So it is using 1111. What if I create another OSPF? What will happen if I create another OSPF? I'm creating another OSPF. When you create another OSPF and if you don't give manually, it is going to pick the biggest IP address from the physical interface. So automatically this router ID 200 will be taken. Did you understand? So we understand here process ID, we understand here router ID. Now we need to understand the area ID. Area ID is to identify to which area the OSPF interface, very important, interface, OSPF, not the router, interface belong. Area ID is to identify to which area the OSPF interface belong. For example, you see this picture here. This interface belong to area 0. This interface of the same router belong to area 2. You see, that is what area ID is. Area ID is to identify the area to which the interface belong. Process ID is to identify the OSPF process on a router. And router ID is to identify the OSPF router, which can be manually configured. If you don't manually configure, it will not prefer physical interface address. It focuses on the loopback interface. When you have more than one loopback interface, it picks the loopback interface address bigger. And when you create another OSPF with different process ID, it will pick another loopback interface address. If there is no loopback interface, only then it will prefer the biggest IP address on the physical interface. Is this clear? Sorry, anyone is asking question? I heard one clear. What about the other person? Mm-hmm. Ah, See, question is this. When I configure the first OSPF, it will pick the biggest IP address from the loopback interface. When I configure a second OSPF, after ignoring that already elected one, it will see the other loopbacks. Already elected, already used one, it won't compare. It will ignore that one. And then after ignoring 5555, it will check how many loopback interfaces are there. If there is only one, it will take that one. If you have more than one, then it will again compare which one is bigger. And when there is no loopback interface at all, only then it will compare the physical interface. In physical interface, one is with 200, one is with 50. So it will take 200 as the route rate. You got it? I would like to show you. Yeah, OSPF1 has taken 40, OSPF2 has taken 10 automatically. Now, if I create another OSPF, what route rate it will take? Exactly, not 100 on one. What you said is correct, 200, the biggest among the physical. It won't consider loopback because loopbacks are already consumed. Let's go and verify now. Show IP protocol. You see, OSPF1 is 40, OSPF2 is 10, and OSPF3 is 200. Right? So do this and see